I didn't put negative x squared into my thing. That's what
All right, today.
I knew it was too easy.
Oh, hello. Today is the last section for this chapter. So we gotta fill in 3 more derivatives. And that's all the derivatives you gotta know for the AP exam.
Wait, what are the derivatives we're learning now?
Huh?
What are the new ones we're learning?
He's gonna tell us.
Yeah. Right now, three more new ones. So here. So we need to know e to the box, natural log box.
Yeah.
So you know what? A to the box and natural log box. That's what we have to know. Now I can derive all of these for you. I think it's the simplest if I just tell you though,
Yeah.
since we're AP.
Oh yeah.
Yes, sir.
Okay, so if you have y equal e to the x, the derivative, the reason why e is such a special number, because why did we even learn the number e? Just so teachers have jobs? No, because e is special, and it's special because the derivative of e to the x is e to the x. That's what's special about it. There's only 2 functions where you take the derivative of it, you take the derivative and you get itself. That's one of them. What's the other one? What's the only other function where you take the derivative and you get itself? Zero, that's right. The derivative of 0 is 0. Those are the only 2. So if the derivative of e to the x is e to the x, what's the derivative of e to the box? Is it just e to the box?
Yes.
No, why do you guys keep saying yes? No, the chain rule. E to the box times the derivative of box. Now, a to the u, a is a number now, like 2. It's any number that's not e, because if it's e, then you use this rule. So like if you have 2 to the box, 3 to the box, 5 to the box, then you use this rule. So the derivative of this one is a to the box times natural log a times the derivative of box. And actually, you can apply it to this one here if you wanted to, right? Because e is a number. So if you wanted to,
Oh, natural.
like if you have the derivative of e to the box, you could go e to the box times natural log e times the derivative of box. But what is the natural log of e?
1.
1. So it's like the same thing, right? See how the formulas all work out if you do correct mathematics? And the derivative of natural log box is simply 1 over box times the derivative of box. Those are the 3 derivatives we're adding to the list today. Okay, so now you gotta learn when to use it though. Okay, let's start off easy. Whoa! Y equal x squared e to the 3x. How would you take the derivative of that? Well, I see a product. Use the product rule. Right? So derivative of the first, leave the second one alone. Leave the first one alone. Derivative of the second. So what's the derivative of e to the box? We just learned it over there. E to the box times the derivative of the box. The derivative of 3x is 3. Easy. Okay, but here's the hard part. Now you're gonna factor it and make a number line. That's what you're gonna be doing next chapter. Well, in this chapter, you're at least gonna be able to factor. What can I factor out?
E.
E to the 3x and an x. What's left?
2
2 plus
times 3.
3x. Okay, so that would be your answer. That's how you simplify it. You have it factored. And then next chapter, in fact, even in this chapter, I'm going to make you make a number line. How would you make a number line for this? What makes that 0? 0. What makes this 0? Negative 2/3. What makes that 0? What makes this 0?
Nothing.
Nothing, that's right. E to the anything is always positive, right? Just look at the graph. The graph of e to the x, doesn't it look like this? It's always above the x-axis. It's always positive. So Anytime you have e to the gorilla, it's always positive. So in other words, it doesn't even contribute to your number line. It's like not even there. So if you plug in a number bigger than 0, like 1, then you get positive times positive times positive, which is positive. And then I know they alternate because these two things have odd powers on them, and that's how you make your number line. But you have to be able to factor before you can make the number line. Okay, what if you saw something like this? Y equal x e to the negative 2x. Now, do I want to change it to this and use the quotient rule? Or do you think it's better to use the product rule? Well, either way, it doesn't matter. But by now, you guys have your favorite, right? Mr. Park, I don't like either. Well, I prefer the product rule. So I would do this, but you can also do quotient rule. In fact, you know what? Let's do both and see which one you like better. Okay, so if I use the product rule, derivative of the first, leave the second one alone. Leave the first one alone. Now what's the derivative of e to the box? E to the box times the derivative of the box. The derivative of negative 2x is simply negative 2. Okay, and then you factor it. What can be factored out? E to the negative 2x, what's left?
1 plus
1 minus 2x. So 1/2 would go on the number line. Okay, but what if we did the quotient rule? Let's do it over here. So using the quotient rule, you would get low d high minus high. And what is the derivative of low? E to the box. E to the box times the derivative of box. All over denominator squared we go. So that's e to the 2x squared. Okay, simplify that. What can I factor out on the top? E to the 2x. What's going to be left? 1 minus 2x. And then what's on the bottom? What do you do with the exponents? You got to multiply them. So e to the 4x. But then you can simplify this. What do you do with the exponents when you're dividing?
Subtract.
You subtract, so that would be e to the negative 2x, 1 minus 2x. Isn't that the same thing? But can you see product rule is just a little bit easier, yeah? Yeah, so it's up to you. I mean, as long as you do correct mathematics, it's going to come out. Okay, now what about that second one? Let's look at some of those. What if you have 2 to the sine x power? See how this is a constant? This is a constant. So this a is a constant. It's a number. 2, 5, 7, whatever. Okay, so this is a to the u. Just follow the rule. The derivative is a to the u times natural log a times the derivative of u, which is like the derivative of the box. Cosine x. That's it. That's your answer right there. Can't really do much with that. You just gotta kind of memorize that one. Okay, and then the last one. This is why e is such a special number. Look how nice the derivative of natural log box is. 1 over box times derivative of box. That's a nice derivative. So here we go. Y equal natural log sine x. Now let's do cosine x. What's the derivative of natural log box? Is it just 1 over box? No, you gotta times it by the derivative of box, which is negative sine x. And then of course, you simplify it to negative tangent x. That's the hardest part, is to simplify. So again, see, the rules of calculus are very simple. You can memorize it, you just apply the rule, but then the hard part is, okay, simplify and make a number line. That's what you're gonna have to do. Okay, let's do another one. Y equal natural log secant x plus tangent x. See, this is the kind I would give you on the quiz which is next week, because it simplifies nicely. Okay, what's the derivative of natural log box? 1 over box times the derivative of the box. Do we even remember?
Secant x tangent.
secant x tangent x
Secant
plus
squared.
secant squared x. Mr. Park, how do you simplify this? Well, can you factor this part here? Can you factor out something?
Yes.
Yeah, you can factor out a secant, and what's left?
Secant.
Tangent x plus secant x. But the bottom is secant x plus tangent x. So don't these cancel? Final answer, survey says secant x. That's the kind I like to give. Oh, and I want to show you something before I move on. What if you had to take the derivative of this? I think this is one of the homework problems. That natural log of x squared. Now, most of you are just tempted to use the formula, yeah? What's the derivative of natural log box? 1 over box times the derivative of box. 2x. X's cancel out, final answer? 2 over x. And there's nothing wrong with that. However, if you use your properties of logarithms, you can make this problem a little simpler. Remember your properties of logarithms? When you have a log, and that's a power, what can they do with the power? Put it in the front. So if I move the 2 in the front, then if I want to take the derivative, you throw the constant on the side like an unwanted pet, yeah, times the derivative of that, which is 1 over x. There you go, same answer, right? 2 over x is the same thing as 2 times 1 over x. But it's up to you. That one, it doesn't save you that much time. Oh, okay, so what if you have a log that's not natural log, like log base 3 of x? You're going to have several of these on your homework tonight. What do you do? I don't see it on the list, Mr. Park. What do you do?
Natural log.
Which means,
Throw it on both sides.
okay, no. No.
X over ln.
There you go. You change the base.
Oh,
You remember the change of base formula from last year?
no.
See, that's the problem with pre-calculus books. So let's review the change of base formula, which is in the notes. If you have log base b of a, and you want to, see, that's why in pre-calculus, hopefully, did you guys just change everything to natural logs? Because in calculus, everything is natural log. So natural log a over natural log b. This is called the change of base formula. And it's easy to remember. All you gotta do, you see put the top number on the top and the bottom number on the bottom. That's how it works. So if you saw this, we don't know a formula for this, so we change the base. So this is natural log x over natural log 3. See how the top goes on the top and the bottom goes on the bottom? Yeah, but Mr. Park, they're not going to use quotient rule. No, this is a constant. If you have a constant, throw it on the side like an unwanted pet. You guys know what I mean by a constant? It's a number. You can punch that in on your calculator. It's like 1.1 or something. Anyway, this is a number, so you toss it on the side. And then what is the derivative of natural log x? 1 over x, and there's your derivative. Of course, you want to write it like this though, yeah? It just looks nicer like that. So anytime you see a log that's not base e, you change the base, and then it's easy. And even if you did use the quotient rule, here, what about those of you who, no, I want to use quotient rule, okay? Low, d high, minus high, d low. What's the derivative of natural log 3 since it's a constant?
0.
0. All over denominator squared we go. So that's 0. Isn't that the same answer? So yeah, even if you did quotient rule, it's going to come out. Any correct mathematics, it's going to come out. Okay, and then the last thing for today. You have to know the difference between these 3 derivatives, because every year I'm going to erase this. There's a problem. So like, what is the difference between like x to the third, 3 to the x, and x to the x? Okay, well we already know. What's the derivative of x to the third?
Yes.
Yeah, so you put the power in the front, reduce it by 1. This is called the power rule. You can only use the power rule when you have x to a number power. In other words, the constant is in the exponent. What about this one? Hey, we just learned that one. Isn't this the a to the u rule?
Yeah.
So this is the a to the u. So the derivative of that is a to the u times natural log a times the derivative of that, of course, which is just 1, yeah? But what do I do with this? Can I use either of these two rules?
No.
No, see, this is like a x to a number power. This is a number to the x power. So you can kind of think of this as like a polynomial. This is an exponential function, but what is this? Well, it's neither, so you cannot use either rule. Do not, because I guarantee you on the AP exam, you're gonna have, they're gonna do this. Oh, the derivative is put the power in the front and then reduce it by 1. Do not fall for that. You can only use the power rule when the power is a constant. You can only use the a to the u rule when the base is a constant. So if neither is a constant, there's only one way you can take the derivative. Natural log both sides. It's called, this technique is called logarithmic differentiation. It's not difficult. The name is just scary. Logarithmic differentiation. That just means natural log both sides before you take the derivative. That's the only way. Okay, so you have this, natural log both sides. Now, why do you think I'm going to natural log both sides?
Because now you can.
Because now you can put the power in the front, and that makes all the difference in the world. So if I bring the power, but you can only do that when you have a logarithm, that's why. So take the power and put it in the front, and once you do that, how do you think I can get y prime out of this?
Implicit.
Implicit differentiation, exactly. Which you had just had a quiz on, right? So, what's the derivative of natural log box? 1 over box times the derivative of box, y prime. Equals, and then over here I have a product, so you just use the product rule. Derivative of the first, leave the second one alone. Leave the first one alone. And what's the derivative of natural log x? 1 over x times 1. And then all you have to do to find y prime is multiply both sides by y. So it's going to be y times, then you just simplify this. 1 times natural log x is natural log x times 1 over x is 1. And you can leave your answer like that. However, if it's a multiple choice, I guarantee you, what can I substitute for y? The original thing. So x to the x times natural log x plus 1. So anytime neither of these is a constant, you have to do logarithmic differentiation. So I think on tonight's homework, I think this is one of them. I think. And then this might be another one. See how neither of them is a constant? So the only way you can do these problems is you got to natural log both sides before you start. This is all technique. So once we learn how to compute derivatives, then that's our next chapter. Then the title is called Applications of Derivatives. Then we're going to actually use it to solve problems. But you can't really do that until you know how to take derivatives. And that's what this whole chapter was about. So that's it. We have our whole list. We just got to commit that to memory. And we got, along with the product rule, quotient rule, power rule, and chain rule, we should be good. Oh, one other thing. Sometimes the book writes this. You know what that means? They're not going to write this on the AP exam, but this is what your book wrote. So it's kind of like a trig function. This is like natural log x, quantity cubed. That's what that means. Because there's a big difference between this and this. See, this one, you can put the 3 in the front, right? Properties of logarithm. This one, you cannot drop the 3 down. So you gotta, there's a big difference between the two. So how would you take the derivative of this? What would you do? This is like box cubed. So 3 box squared times the derivative of box. 1 over x. That's how you take the derivative. All right, so we are done. 9 minutes left. Go home early then? Oh, question.
For that one, like, how do you know when you need to plug in a Y and when you can just leave it as a Y?
Well, you can leave it, except that I'm telling you on the, if it's a multiple choice, you gotta pick out the answer. They always substitute the thing in for it, so you gotta constantly looking for that. But if it's a free response question, that's perfectly fine. Okay, we're done. Let's go home, unless you got another class.